In this IO streams topic, in the last topic we discussed piped input stream, piped output stream, sequence input stream, file name filter demo, and file object examples. And here in this topic, we are discussing object serialization. Object serialization is one of the common concept in most of the object-oriented programming languages. Object-oriented programming languages, that too the languages which are having network capability. I need not have to specially say network capability, because every nowadays programming language is having IO API, networking API common. So, if a programming language is having object-oriented programming capabilities and network programming capabilities, in such cases we can use this object serialization concept. Converting object into stream of bytes. So, if this object serialization concept doesn't exist, Java cannot be used in distributed applications, like especially RMI, Corba, EJB. SOAP and RESTful based web services are completely using HTTP protocol. HTTP protocol with XML or JSON. Here in web services, we don't need object serialization. Same object serialization is replaced with converting object into XML format or JSON format in web services. But before web services, the traditional Java distributed technologies like RMI, Corba, EJB, they uses this object serialization concept to send the data from one machine to another machine. Now I am going to give you a demo on this how object is converted into stream of bytes. Here is one small example. Here is one small example on RMI, Corba, EJB. All distributed technologies remain same. The name distributed application development mean. The name distributed application development mean the application is distributed all over the network. Say for example, we are developing one healthcare application. We are developing one healthcare application or employee payroll application or students information or any kind. Here we are developing one healthcare application. In this healthcare application will run on the hospital. This healthcare application will run in the hospital. And this hospital application is accessed from hospital website. This hospital application can be accessed from hospital website. And it can be accessed from mobile apps. It can be accessed from mobile apps. Or it can be sometimes accessed by the web applications written in PHP or ASP or Python or some server side like Node, JS, Express.js, like etc. applications. And sometimes this application want to be used by interoperable distributed applications, and sometimes want to be accessed by distributed applications of the same, or web applications or mobile applications. And then one healthcare application is running in one machine. That application want to be accessed from applications running on other machines. So here in this healthcare application, say for example, when a patient comes, we'll note down the patient health complaint, like feeling with fever, cold, cough, body pains, toothache, etc. The moment patient comes and tells the health complaint in the reception, the receptionist will immediately takes the appointment of a doctor. And also, if patient brings any clinical tests, then, for example, first time when patient comes, the appointment will be given, clinical tests will be blank. Later on, if doctor prescribes any clinical tests like a blood test or urine or any other test kind, so patient will go to the clinical laboratory, gets a test done, takes the reports, and again comes back and takes the appointment. That time, the appointment object and the clinical test array, because no different tests will come. So that array and appointment array patient is having, one appointment will be booked. What that appointment contains is, that appointment contains, during that appointment whatever prescription is given, before that, before visiting the doctor, the junior doctors or nurses will take the weight, height, the blood pressure, BP, temperature, and this kind of the basic health signs will be taken by the junior doctors or the nurses before sending the patient to the doctor. Once the patient reaches to the doctor, doctor will ask some questions to the patient and he'll give a prescription. So health sign contains the sign and value, and the BP its value, temperature its value, weight its value, height its value, etc. Like the next again, prescription. Prescription contains medicine dose for how many number of days. So one appointment contains a prescription prescription contains many medicines doses and this data, and actually a prescription contains so many number of prescription items. Actually, these are not prescription items are stored, and the next various health signs. And in each appointment, the patient, different health signs, different prescription data will be stored into an appointment. The doctor data, etc., also exists. Such appointment, many appointments a patient will take. That is what our hospital management application consists of. Almost 4 classes. And here there will be one more class called appointment server. Before coming to the appointment server, we want to discuss about appointment manager. Class appointment manager. This appointment manager class is having, and these are the classes exist on server system. That means in the hospital. So appointment manager class is having various functions called book appointment, view all appointments. In the book appointment, if patient object is passed to that patient, new appointment will be booked. View appointment, if appointment ID is passed is augmented, that patient will come, from that we can get all the we can get the patient and as well as appointment details. View appointment, view all appointments will return. Actually, view all appointment could return appointment array type of object. So, like that appointment on manager class we have written. This class will internally use all these classes. And this class is having 3 methods called book appointment, and view all appointments. These are the business logic functions. These business logic functions will use, internally uses this data transfer objects. Data transfer. This is called as data access object. This is called as data transfer objects or value objects or entity objects or job in objects or POJOs, entities, domain objects. You can call with different names. So these methods will internally use these objects. And this method, by using these objects, also interacts with the database through a JDBC or Hibernate or JPA or through any other mechanism. So such a appointment manager class object and its methods must be, along with all these 4 classes, must be exposed to the client. Then what to do? So for this appointment manager class, and it should become a remote application, it should have a remote interface, and it should have one stub, one skeleton. A server class, in the distributed application, a server class will create this appointment manager class object. Appointment manager class object is registered into a registry. Every distributed application document contains a registry. UDDI registry, the next in the Spring Boot with microservices, we call it as Eureka naming service. In Spring Boot with microservice, we call Eureka naming service. In the SOAP-based web services, there we'll use one registry called UDDI registry, Universal Discovery and Data Integration. And in RMA, we'll use RMI registry. In Corba, we'll use IOP registry. In EJB, WebLogic, we'll use T3 registry. in Windows networking environment, Active Directory service to register all the nodes exist in the network. So every distributed application development, every client server application development uses one registry like this. So here the appointment server creates appointment manager class object, and this remote object is first registered into naming registry. The object is registered into naming registry. To the client also, we should pass all these classes. All these Java bean objects should be shared. This appointment manager interface, its stub class, all this should be shared to the client. Client, what he does is, client will look up into registry. He'll get the remote object reference, and to that remote object reference, client will make the call. And from client, the book appointment, view all appointment methods will be called. Methods will actually execute on the server system, but call will come from the client. There is a call is coming from client to server, and server runs on server system. That is why the application is called as distributed application. And the request comes from one machine and execution performs on the different machine. Generally, an application, the execution and client request both are generally made into one single system, but here it is distributed into two different machines. So, whatever beans that this server system uses, this EM beans must be used on server side also. These classes must be given to server also. Plus this remote class interface stubs also must be given to client. Anyway, this is a distributed application of it. But in this application, when client makes a request to book an appointment or view all appointments, array of all these class objects must be sent from server to client. Classes exist on client also. Classes exist on server and client also. But how these class objects, usually an object can be used only within the JVM. But here the objects of these classes created in this application must move from server system to client system, and sometimes from client system to server system. How objects will move? Objects, their state will move. Object means it points to some memory. For a class, some memory is allocated, that is called as one object. In that object memory, that class variable, instance variable values exist. That is called as object state. But in this distributed application development, the object's state want to move from client to server, server to client. How that happens? How class object's state will move from client to server, server to client? So in order to do this, the classes whose state want to move from client to server or server to client system, these classes must implement from one interface called java.io.serializable. I'll show you that. I'll show you with one example. So in Java, you can ask me, other than our classes. Okay, now hope you understood where object serialization will come into picture, where object serialization is essential. In distributed application development, object serialization is essential. If object serialization doesn't exist, no class object in one machine can move. Object state can move from one machine to another machine. Absolutely no. Before this, you can ask me, is Java API is having any such serializable classes or not? Such serializable classes, yes. Java is having plenty of serializable classes, and I cannot exactly say half of the API or 1/4 of the API, exactly not count like that. But some of the classes, like all wrapper classes, byte, short, integer, long, float, double, character, boolean, string buffer and string builder, they manipulate string object, but they are not data types or wrapper classes, not string buffer and string, but string. All wrapper classes are under string buffer, string builder, and all numbers of classes and that byte to double. Then next, exceptions, all checked exceptions and unchecked exceptions, and all classes which are derived from exception and random exception classes. All collection classes and array list to, hash set to, linked hash set to, array list to, linked list to, hash set to, linked hash set to, tree set to, hash map, linked hash map, tree map. All collection classes, vector, hash table, properties, all these collection new classes and old classes are all serializable classes. All AWT and Swing user interface classes are serializable. All servlet classes are serializable. All remote object used parameters in the method and method written types In the distributed application, whatever classes we use as parameters and written types, they all must be subclasses of serializable. And all the connections written from the JDBC connection pooling are all must be serializable. So that, I cannot say, but majority of the classes, not that most of the classes in Java API are serializable. And there are some non-serializable classes exist like threads. Threads only runs on one machine. The state don't move from one machine to another machine, right? Thread makes multiple methods, runs on one single system. So their state need not be moved from one machine to another machine. Thread need not be serializable. IO streams. IO stream classes like object output stream and object input stream makes object serialization possible. But input output stream classes, they do writing and reading, but they need not be serialized. IO streams and networking. Similarly, socket and server socket in the networking. So where socket and server socket will communicate between client and server system. And the objects passed through sockets must be serializable. Socket and server socket need not be serializable. System, object, runtime, JDBC interfaces, their classes, they are all not non-serializable. They are not serializable. They are all non-serializable. So, if the object serialization doesn't exist in Java, networking based applications are not possible. If serialization concept doesn't exist in Java, network based applications or web board, distributed business, interoperable and integration application developments are not possible at all. The purpose of object serialization is, for instance, if we create 100, and this is another example. Suppose, if you can't understand distributed application for this moment, for a small example sake, here I can show you an example. The example is, I'll write one class, employee class. To the employee class, I'll create some 10 objects or 100 objects. Each employee object contains different employees' data that our organization is having. So we want to write one client. Through that client, all these 10 employee objects are 100 employee objects. These objects internal state means the values exist in the instance variables of this class. This called as, one object state is nothing but the instance variable values of that object is called as object state. And variables exist in the employee class. For in each object, for the instance variables, memory exists, right? In that instance variables, the values are called as object state. Like that, 10 or 100 employee objects are created. We want to write one client program. Here we created 10 employee objects, E1, E2, E3, like that, up to 10. And we used all the employee objects in this program. At a point of time, the program execution ends, the main method execution ends, all the 10 employee objects are destroyed. All the 10 employee objects are destroyed. But we want a mechanism in such a way that these 10 employee objects are the objects which we want to use regularly in our application. So, for example, I'll give you a best example. If you take in each branch, we may be having some number of students. Say, for example, in CSE branch, we are having 60 students in one section. Suppose if there are 240, 250 students are if admitted in the CSE, we make four sections. Each section contains 60, 120, 180, 240 students. We make 240 students divided into 4 branches. In each section, the student number 1 to student number 60 of one section. Similarly, section 2, section 3, section 4. Each section contains 60 students. Throughout that academic year, and maybe next year sections may change, but at least for that year, the students exist in one section, the 60 students. Their names, their roll numbers, the students remain same. So once from the master database, the students' details are retrieved at the beginning of the academic, throughout the semester, throughout the year, not throughout the semester, throughout the year, to those 60 students, attendance, marks, feedbacks, whatever you want to maintain, those 60 students' data of one section will remain same for the entire year. Do you need Do you fetch the student's data every day from the master database? Do you fetch the student data every day from the master database? If do so, a server is such a server that server will be accessed by accounts department, marketing department, admissions department, branches, library, stationery, that, this. So many different departments, different people will access the master data every day to mark the student attendance. If you retrieve the student details from the database every day, the load on the main database will be increased. The burden will increase. So during the beginning of the academic year, we want to fetch 60 students of one department, one section, one branch, one section. We'll store it somewhere into local file, in the hard disk, in the local file, and retrieve from the hard disk and store it into local hard disk. And throughout the year, use the student data only by retrieving from the hard disk, modify something and write it into hard disk. Read next day, modify something and write it into the hard disk. Reading and writing from the file is less expensive than reading and writing from the database. Expensive because of our continuous read and write operations on the database. Others access of the data will be get affected. Performance will impact. Network load will increase. But writing and reading to and from the file of that section in charge people, load may not be impacted. Performance may not be impacted. Can you do that? Similarly, employees, the day when they join, whatever the data they give, their name, their surname, their caste, religion, their date of birth, father name, mother name, spouse name, or whatever it is, whatever the data that employee gives during the first day, the data will remain till the employee goes out of the company. Data will not change. Email ID, mobile number, date of birth, etc., etc. So every time, instead of accessing the employee data from the database, first time you access the employee data from the master database once, store it into employee objects, write it into hard disk. Daily you read from the hard disk, employee objects, all 100 employee objects, mark their attendance, write them again. Read tomorrow, make some changes, mark the attendance, write again. So writing and reading from the hard disk doesn't increase the network load or database load, or doesn't impact the performance. So in such cases, we can use this object serialization. So what you do is you create 10 employee objects or 100 employee objects. In iOS Teams, there is one class called Object Output Stream. This Object Output Stream must be pointing to File Output Stream. File Output Stream object must be pointing to some file name called employee.serializable file. Object Output Stream class is having one method called write object. In the write object method, if you give each and every object, employee 1 object, employee 2 object, employee 3 object, employee 4 object, employee 3 object, employee 4 object, employee 5 object, like that. In the write object method, each object you pass into write object method, the object output stream will write it into this file as a stream of bytes. And previously we saw reading and writing byte by byte, reading and writing line by line, reading and writing buffer by buffer. Now reading and writing object by object. It's a different concept. So far we have not encountered reading and writing objects that you can do through this object output stream and object input stream. Object output stream makes one condition. It makes one condition. The condition is whichever object you pass as argument into write object method, whichever object you pass as argument into write object method, employee object, prior to that, the employee class must implement from serializable named one interface. Serializable named one interface is there in Java.io package. Classes, those whose objects want to be serialized, such classes must implement from serializable interface. If not, the object serialization will fail. If you do so and write 10 objects into serializable file, another client can read object by object from the serializable file into 10 different employee objects and can use it. So classes, those who are not implemented from serializable, are not eligible for serialization. Same thing. And it can be used to write the objects into local file system, and tomorrow you can read it like that throughout the year or throughout the semester or for a lifelong of the employee. Or it can be used the object sharing across between client and server. To share the object state across between client and server also we can use this iOS streams like that. To implement serializable classes, the class must implement from java.io.serializable interface. I'll show you example. Department class. This interface is not having any method. If you ask me, if the class implements from serializable interface, is class will get any special functions or variables? No. Serializable interface is not having any variables or functions. But class which is implemented from serializable interface, that makes mark on the class that this class object can be serialized. And it is one kind of permission giving class. And then during, if a class object want to be serialized, it should have a permission that it should get a signature from the HOD or principal or a class in charge saying that okay, the student can go out of the college for this day because of so and so reason, medical reason or personal reason or some home reason. Do you get that letter? That letter you should show it to the what you call security. Then only security will, without permission letter, will the security will allow you to go out of the college during the college time? Similarly, that permission letter kind is in serializable interface. Class which is not implemented from serializable interface is not having any permission to get serialized. So who will check whether the class is implemented from serializable or serializable interface or not? Which class method is serializing the object output stream class write object method? So the moment you pass any object as argument into object output stream class write object method, the write object method will internally check, is this object instance of serializable or not? If it is not serializable, simply it throws one exception called not serializable exception. If class is implemented from serializable, then it's simply serialized object. How to serialize that object output stream class write object method will take care. How to deserialize object, that object input stream class read object method will take care. But the object which are passing into write object and read object, the class must ensure that I am implemented from serializable, otherwise the object will be rejected. But this interface will act like a marker or recognizer to see the ability of class whether class can be serializable or not. That's what. All primitive variables declared in a class. All primitive variables declared in a class are eligible for serialization except transient variables. Transient is one access modifier, right? In the employee class, you declare employee ID, employee name, salary, designation. While serializing employee object, employee ID, employee name, salary, designation, everything will be serialized. But in the employee class, we store one variable called bank account number. Bank account number want to be somewhat confidential. Or the employee Aadhaar card number, or PAN number, or bank account number, or something, a PIN number, something, some confidential data. In employee object, as long as employee object exists, this normal data and confidential data also want to be available. But once the object gets serialized, this common data can be serialized, but this confidential information do not want to be serialized. So how to mark variables that do not want to participate in the object serialization? By declaring them as transient. Transient is an access modifier that acts as a marker for the variables that do not want to participate in object serialization. So all primitive variables declared in a class all are eligible for serialization except transient and static variables also. It's because static variables, their memory exists in the class memory but not in the object memory. During object serialization, object state is serialized but not class state is not serialized. So that's why they cannot participate in serialization. Any other class objects created in our class, and suppose there is a class A. The class A object is used in B. B class object is used in C. So when you are serializing B object, in the B object exists, that also must be serializable. In the B class, we use A class object. A class also must be implemented from serializable. So during C object serialization, if B or A are not serializable, The rest of the C object is serialized, B object is get serialized, but B object containing A object, because it's not implemented from serializable, that cannot be serialized. So such a caution we have to take care. Any other class objects created in our class are, if implemented from serializable interface, are only serialized during our object serialization. Non-serializable class objects, if exist in our during object serialization, they are not serialized. But our object deserialization, during our object deserialization, those non-serializable objects are reinitialized to null. Their state cannot be persistent. Forget about deserialization. During that process, we will get cannot serialize exception. Here, department is a class that implements some serializable. How many variables department class having? Department number, department name, and location. List of employees. Where is employee? Here is employee. Department class constructor takes no parameter constructor. One parameter constructor takes department number, department name, location, list of employees. Initialized to class instance variables. To string will print the department state as a string. Right. Next. Employee class is also implemented from serializable. Remember, employee number, employee name, salary, designation. Transient string bank account number, department D. And then whenever you serialize department object, one department object with list of employees, the entire department object state, department number, department name, location. All list of employee objects, including each and every employee objects, employee number, employee name, salary, designation, are all get serialized except this bank account number, because that is we want to maintain that that account number, employee account number as a confidential data. Such confidential variables are declared as transient. Transient means not persistent, which cannot be saved. Transient is opposite to persistent or serialization. Transient variables cannot be serialized. So this is about employee class. Here is the department serialization demo. Here we created 4 employee objects: employee ID, employee name, salary, designation, and two more arguments are there: bank account number and department. If you are interested, you can fill them. So 4 employee objects are created. To store all the 4 employee objects, we created an array list object. In the array list, and the array list comes in the util package collection API. In the array list class, add method is given. In the add method, if you give each employee object is added to list. Objects are added to array list. Now, the object serialization process starts. Here, such all array of employee objects exist in the list are given to department object. In the department object, department number, department name, location, and list of employee objects are given. Then, how to write into file? This object state into file. First, one file output same object must be pointing to file department.serializable. That file output same object must be given as argument to object output same class constructor. Okay, now through a object output same, if you write any data, the data will be written to file output same. File output same will write the data into the serializable. So, what is the method available in object output same class? Object output same class is having one method called write object. In that, if you give any object, that object will be written to destination file. os.write object. But in this case, you please make sure that the object which is given here in the write object method, this object's corresponding class must be implemented from serializable. If this class contains any other class objects like employee objects, department object class contains, that employee class also must be implemented from serializable. Otherwise, not serializable exception will be thrown. In Java, the actual object serialization is performed by object output same class write object method, but not by Java. Many faculty, students, many presenters will tells that the object serialization is performed by JVM, but which is a misleading concept. Object serialization is not performed by JVM. JVM is having its own role. Object serialization is not the responsibility of the JVM. Once again, I am reminding you. Object serialization is performed by object output same class write object method. This method will internally checks whether an object comes here. This method will internally check whether this each object is an instance of serializable or not. But many faculties think that object serialization is performed with JVM. Absolutely wrong. If object corresponding class is not implemented from serializable interface, then passing such object into write object method raises not a serializable exception. And internally, this is how the object is an instance of serializable or not will be internally checked like this. Finally, object output SIM and file output SIM objects are closed. Here we are writing a deserialization program. Here, through file input stream, we are reading from department.serializable. That file input stream we are giving to object input stream. Object input stream.read object. Object input stream.read object will read the which object? We wrote only one object, department object. Hence, the object we typecast into department. Printed it. We are confidently printing each object because in every department and employee class, we have overridden toString method, remember. Because of if you give department object to system ... print internally, this toString method will be called, that will print the employee object state as is. If the toString method is not implemented, something else will be printed. That you have to take care. So department.employee list we called. See here, in the department class we are having employee list variable that we received into one list object. List.iterator, this is collection API. List.iterator, iterator object will come. Iterator is a pointer pointing to the list of objects exist in the array list. Iterator points, acts as a pointer to each element in the list. This has next method will look for each object. Next method will return that object. So same thing we are doing here. Iterator.hasNext will go and check whether the next object is available or not. If exists, the next method will return that object. You call next method, that will return the object. So what type of objects will come through that list? Employee objects. So you typecast each object into employee, print the employee. This is how deserialization program is completed. For the demonstration sake, we serialize and deserialize objects within the same machine. But in real-time application, the objects will move from socket from one machine to socket into another machine. And sockets, object input streams, socket output stream, object output stream combination, socket input stream, object input stream combination must be used in client and server system to share the state of the objects. So, this is how we end up our session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.